Hi to all. In this quick video, we will talk about interest rate swaps, and we will continue working on the calculation of the price of an interest rate swap, the value, and the quarterly payment. So first of all, just a very quick idea, and let's keep in mind that in interest rate swaps, we have two parties. We have one party, which is the receiver of the fixed uh, rate, and we have another party which is the receiver of the floating, and they may get different names and different depending on different sources, but long story short, the receiver fixed is basically getting fixed payments, whereas uh, the floating receiver is getting floating payments, which are usually attached or calculated based on some benchmark rate that is changing. Those individuals who are usually the fixed receiver fixed are investors who prioritize income stability. And let's think of some individual that has some commitments, and therefore to this individual, income stability is important to make sure that he or she is able to meet this commitment. Therefore, this individual will be happier with a fixed rate, and because in this way there is no uncertainty or risk of interest rates actually coming down, and then the income also coming down, and having some issues meeting these responsibilities or commitments. On the other hand, we have other investors who may prioritize gains or returns. They may be more bolder investors who are just focused on returns rather than on stability. So in this case, these investors may be happy by receiving a floating rate as long as they believe that interest rates are going to move up. This kind of investor, of course, is not likely to enter into an interest rate swap where they are receiving the floating rate if they believe that interest rates are going to come down, but they are rather usually expect interest rates, that rates will go up, right? And that's why they are entering into this floating receiver, into this interest rate swap, right? And let's keep in mind, if they are entering into a swap, that means that they had a fixed rate and they are not happy with it because they believe interest rates are going up. So they are swapping it, and in exchange of a floating rate that they're getting from this receiver fixed. In turn, this receiver fixed has already a floating rate, and this investor is not happy with that floating rate, and therefore it makes sense to this investor to swap it in exchange of a fixed rate that allows for more stability in the income, right? So both are happy, but there is one rate that needs to be decided, and that is that fixed rate. So what is that fixed rate that will make sense to both of these investors, so they agree on this swap, right? And we need to discover that. So very quickly, let's just think of when a floating rate and a fixed rate are sort of matched. And we can think about this when a bond which is trading at par. And I will just go over this rather quickly, but this is important. When a bond is trading at par, it means that the market yield are the same as the coupon rate. So this one is floating, as we know, and then this one is fixed, as we know. This one is the basically stated in the bond. That is the commitment of the bond issuer to pay this fixed amount of money as interest payment throughout the life of a bond, whereas the yields are basically the returns. And one way we can think about the yield is just the returns of or the interest rates that similar bonds with similar features or similar issuers or similar securities are paying for a similar level of risk, right? A comparable level of risk or asset. So when we have a bond trading at par, this is a great example of what that coupon rate should be. So we just look at, okay, what are the yields in the market right now? And then, okay, let's think about this case where this fixed rate is actually the same. So how is this leading us to identifying this fixed rate when we are working with this interest rate swap? Well, let's take a look at this. If a bond is trading at par, then this bond is going to have a value which we can assume is 1, right? 1, we can assume it's also 100, right? But let's simplify it and say that it's simply 1. And that value will come from two components. Number one, the present value of the coupon payment. So we will have coupon 1 discounted by 1 plus r to the power of 1 plus coupon 2 discounted by 1 plus r to the power of 2. So one important thing we will do is we will change from this usual format, and we will say present value factor 1 multiplied by C coupon 1 plus present value factor 2 multiplied by coupon 2, where present value factor 1 is exactly the same as 1 divided by 1 plus r to the power of time, or if we have add-on rates, then it may be also 1 multiplied by r and then some period of days divided by 160 and 360. But long story short, we don't need to worry about this now. It's just that the notation, this is going to be 1 plus r, right? And we are discounting using this present value factor. So instead of having 1 divided by 1.05, we will have 0.99 something, and that we can multiply instead of dividing. So it's exactly the same. It's just so I'm just taking some time and saying these things so you're more clear on what is it that we're doing. So in this case, what we're doing is PV1 times coupon 1 plus P present value factor 2 times coupon 2. But there is one important thing, plus present value 3 plus coupon 3 plus present value 4 times coupon 4. Now there's one important thing here. This is the first component of the price of a bond, and then the last one will be PVT, which is whatever the terminal year is. If it's 4, let's assume that this would be 4, and then we would multiply that by the face value. And the face value, if a bond is trading at par, is going to be the same as the price. So it's going to be 1 in this case because the bond is trading at par. So let's focus on this first component here. And in this first component, now we acknowledge that coupons are fixed payments. So we don't have 1, 2, 3, 4. We only have C because it's always the same amount of money that is being paid. And then we have this. If we want to make it more general, plus ... and plus PVT of C, right? Now, and let me move this one a little bit lower, okay? So once we have that, then we can factor out, because we see that this C in all of these cases is the same, so we can factor it out. And then, as a matter of fact, let me take this off here. And then we can simplify things up and say, well, 1 is going to be the same as C multiplied by PV1 plus PV2 plus PV3 plus ... plus PVT. And once we have this, then we can simplify this and simply say, well, let's say this is coupon multiplied by the summation, meaning in I going to T of PV, right? And then that's it. Now, let's not forget this. So we need as well to add this PVT. And what is this PVT? Is the present value that corresponds, the present value factor that corresponds to that last period of time, right? This. So now we don't even need this 1 because multiplying by 1 is just giving us that PVT. Once we have that, then we should clear for this C. So once again, if we have these present value factors, and these present value factors are coming from, are varying according to the different rates in the market. And then we have this C that is not varying. So we want to clear for the C that conditional on these present value factors, we want to know what that rate, that fixed rate should be. So finally, we can clear this by moving this PVT here to the left-hand side. And once we do that, and let me do it step by step, we will have this. And now we can move this to the left-hand side as well. And so we can remove it from here. So that's C. So if I then, let me just move C here instead of here. And there we go. So that is the formula we will use, and this is the terminal present value factor, and then this is the sum of all present value factors. So now let's move to Excel so we can quickly work on this problem, and then the other interest rate, the other swaps such as equity swaps or currency swaps, we are not going to go over this detail anymore, but we will still use this formula in these swaps as well. Okay, so if we go here, I have this problem where you have an interest rate swap, and considering below information, now we are asked what is the price, what are the quarterly payments, and what is the value. So first thing, we saw these present value factors, we need to calculate them. So let's calculate the present value factors. So what we learned before is that present value factors are 1 divided by 1 plus r. So like 1 divided by 1 plus r to the power of t, right? And in this case, this is everything is below a period of 1 year. And one way we can get these present value factors is 1 divided by 1 plus this rate. But now we have a problem. Now, we are discounting just by doing this, but we have to acknowledge that this rate is an annual rate. Rates are always stated on an annual basis, but this is 90 days. So if we look at this time to maturity time, right, these are different moments in which we will get payments in this interest rate swap. So in this case, these are quarterly payments happening at, I should have started by saying that 90 days from now, you get a payment, 180 days, you get another payment, 270 days, you get another payment, 360, you get another payment. So the present value factor would be 1 divided by 1 plus this rate, but we need to multiply this rate by 9 divided by 360, right? And if we want to do things a little bit more efficiently, we can just select this period here. We don't need to change the denominator because it's the same. There we go. And then we have our present value factors. We scroll them down. If we look at the last one, you will understand what we did. It's simply 1 divided by 1 plus the rate, but then this rate we are multiplying by, for example, in this case, 360 divided by 360. So in essence, because here we're waiting for the full year, we are just dividing by 1 plus r, which is very intuitive, very straightforward. Once we have the present value factors, then what is the price of the interest rate swap? So one important thing is that we know that the price of the swap is that fixed coupon rate that makes the variable that makes the bond to be trading at par, considering variable yields, and the variable yields are influencing the present value, or reflected in the present value factors, right? So then the formula was that you can look back to the whiteboard. The formula was 1 minus PB, present value factor terminal, and then divided by the sum of PV factors, right? So that is a quite a straightforward formula. I'm gonna give Excel a couple of seconds as it is taking some time to format these cells, and then we will get this price very quickly. So what we will get is this fixed rate. So we are first given these yields because we are having this market interest rates. That's what we are being given here, and those rates may change. But these rates that we have here, Excel is already set. Okay, these rates will change over time. But then, given these rates, we will get this fixed price of the interest rate swap, and that fixed price of the interest rate swap will not change. So if we use our formula, then it's very simple. It's just 1 minus the last present value factor, and then we will divide this by the summation of all present value factors. So if you want, let's do the summation here. And let's add them all up here, and now we can use our formula, which is 1 minus the last present value factor divided by the summation of the present value factors, and then we're done. So now this is, and if we change it to percentage, right, it's 0.59, and that is the price of interest rate swap. One important thing, this is not yet an annual rate. Annualized, that would give us, so we would just divide by 90 divided by 360, because this is a quarterly rate, and we would have this annualized rate, which is 2.38, right? But then this is what we are going to need in most of the things we're working on. For example, when we work with the quarterly payments. So what are the quarterly payments, right? When you have a swap transaction, then the investor who has the fixed rate will receive the fixed rate, and in theory, that fixed payment will be transferred to the fixed receiver. And the investor who initially owns the floating rate will get that floating rate, and then in theory, that floating payment will be transferred to the floating receiver, right? In practice, rather than exchanging all these sums of money, these interest payments completely, the difference is exchanged from one to the other. So what are the quarterly payments here? Then when we look at the quarterly payments, we just need to first, we have this needed amount that I should have introduced earlier, and this needed amount is the amount of money that we are the notional amount. So that's the amount of money that is in theory being swapped, but then we are only concerned about these quarterly payments. So quarterly payments, let me write it here. What is the notional amount that is being exchanged between the two? Well, we're exchanging $100,000. $100 million. And then we're going to multiply, and we can do it in the long way or the short way. We can simply multiply this by the price of interest rate swap quarterly. And there we go. I mean, that's the quarterly payment. It's quite straightforward, right? Another way that you may see in the book is a little bit of a longer formula, which is, well, this notional needed amount multiplied by this annualized price. And then, of course, you need to adjust it using 90 divided by 360 because these are quarterly payments. So, of course, you're not going to get their rate that will go to the that corresponds to the entire year. You're only entitled, because it's paid every quarter, you will only get the quarterly, the proportion that corresponds to that quarter. Okay, and either way, if you do it one way or the other, you're going to get the same amount because basically this multiplication here, it's the same that we already have when we look at this. Okay, so then quarterly. Finally, now one important thing is these are the fixed payments. So what will happen is that the floating payments will be more, will be less, and then depending on that, we will have this difference being exchanged between the two parties, between the two participants in this fixed interest rate swap. So now, one important thing is we will have this value of the interest rate swap, and the value of an interest rate swap is very simple. So the value of the interest rate swap, basically, we have this. Let's assume, let's do this, that 6 months have passed. That's a good way of doing this. And the updated price of our interest rate swap is 0. The updated price of interest rate swap is 0.4%. This is quarterly, right? Or if we divide it by 90 divided by 360, it would be 1.6 annually. But let's use this number, which is a little bit more straightforward. And now, so what is it? What happens here? If the updated price of interest rate swap is now 0.4, that means that now this is the fixed rate that when you do this calculation, present value factors have all changed. You update them, like, oh, now it's 0.92, 0.91, 0.9, right? And you update this present value factors and you will get an updated price right here. Okay, so this is for to make it simpler. Now we are given this price, which is okay. Yeah, we use these present value factors. We calculated the updated price of a swap, and now 6 months later, the price of a swap is no longer 0.59, but now it is 0.40. So then what we will do is we noticed that this rate, if you started an interest rate swap now, your quarterly payments would be much lower. Your quarterly payments would be 100 million multiplied by 0.4. So the quarterly payments would be 400,000 and not 594,000. Okay, so what is the idea behind the value of this interest rate swap? Every quarter you will receive this minus this. You are receiving $194,000 more every quarter compared to an investor who enters into an interest rate swap today. Why are you getting more money in your interest rate swap? Well, because you opened it 6 months ago and interest rates yields were higher. So the contract that you have in your hand has a value, and this value means your contract has this advantage, which is $194,000 more than what it should pay if you're opening it today. Okay, so we can calculate this value here in dollar terms, or we can also calculate it in terms of rates. which is 0.59% multiplied by 0.4. So another way of seeing this is, well, your interest rate swap, which you opened 6 months ago when interest rates are higher, the price of the swap was higher, and therefore you're getting 0.19% more every quarter, which on annual terms is basically annual terms, this is basically 0.78% more annualized than those investors who are entering into an interest rate swap today. So let's keep this representation here, which is just subtracting the 0.59 minus 0.4. So if we multiply this by the notional amount, basically we are getting the same thing, which is we had before. So let me now keep these two. So that's the rate, how price C0 minus C1. And by C, this is just notation. I'm choosing one notation randomly, and I'm coming up with these notations. C0 is the price of the swap 6 months ago. C1 is the rate of the swap today. The difference is 0.19, and then we end up with this Z 0 minus C1 multiplied by the notional amount, or let's simplify this by the amount swapped. And once we have that, then what we can clearly see, okay, let me go back here. So we can clearly see the same number we have been seeing. Now, there is one little thing. We know every quarter we're going to get $194,332.13 more now with our interest rate swap, and I'm emphasizing compared to another investor who is opening the interest rate swap today, because we opened it 6 months ago, and 6 months ago interest rates were higher. I'm iterating. I'm not going to do that in the following videos, but I think that's helpful to help you understand. So now we are missing one thing. If we want to find this value, we need to acknowledge that we have a period of time, and that period of time is a whole year. So we have basically 4 quarters, and we are getting these 4 payments, quarterly payments, and therefore we need to bring these payments to present value. Why? Because we are going to receive $194,000 over the next quarters, and basically the value, what we can consider the value, is just adding those. So 4 quarters times 194,000, then that would give us the value of our swap. But there is one little detail. We need to acknowledge that the cash flows, the difference, this difference, we are happy to get $194,000 more. Some of these quarters are happening later on in time, and therefore we need to discount them. We need to bring them to present value. So how can we do that? Well, number one, we can just discount this fixed amount one by one by the respective present value. So we multiply this one by PV1, and then we repeat this, then we repeat this, we repeat this, we repeat this, and then we multiply this by PV2, by PV3, by PV4, and then we would get the present value, right, of each one of these cash flows. Now, one interesting thing is, rather than doing this multiplied by PV1, then this PV2, then we would add all of them up, and we would get the solution. Rather than doing that, because this is a fixed amount, then we can do exactly the same we did before. We can just multiply this one time by the sum of PV factors, and it is exactly the same. it is simply what we are doing is we are factoring out this payment, and then we just multiply by the sum of all these factors. Just watch the video back, and when we did this, when we were clearing for C, right? So we just multiply that. So now let me take this formula, and I'm going to say that we are going to multiply this by the sum of present value factors. And that is our final formula that we have. There we go. That is the final formula we have. So if we do that, we multiply this by this sum of present value factors, then we have 766,349.15, which means, I mean, rather than multiplying this simply by 4, which is, oh, over the 4 quarters, I'm going to receive these payments. I'm going to receive these payments 4 times, and therefore I'm going to end up with $777,000. We are only multiplying by 3.94 because these are the present value factors. So we acknowledge for this for the discounting effect. So we will get the value, the actual amount we get in it. If we compare ourselves to anybody opening an interest rate swap today, we are getting 766,349.15 in present value terms. So in value terms. Okay, now I'm gonna introduce this formula that we have just stated right here. I'm going to introduce it a little bit more formally here, and I'm gonna change, let me do this. Because this is how you will see it on Canvas. It's just first the amount swapped, then the difference, and then the sum of PVs. So value of an interest rate swap will be equal to this notional amount then multiply by the fixed rate at initiation minus the fixed rate today, multiply by, and let me add the multiplication here too, and then multiply by the sum of PV factors. And that's the formula how you see it here, but now we have clearly figured out this formula step by step from the very beginning. And now you can see what are the quarterly payments, we have it, what is the price, we have it, and then what is the value, we have it as well. Okay, so thank you so much for your attention, and then if you have any questions or concerns, feel free to contact me. Let's keep in touch.